Hey everyone, in this video we're going to be solving a system of linear equations graphically. In order to do that, we need to make sure we can graph a line in any of its forms, so either using the intercepts, in slope-intercept form, or point-slope form. To start us off, does the point -3, 1 lie on the line y equals x plus 4? So in order to answer that question, we're going to substitute -3 in for x and 1 in for y. So we'd get 1 equals -3 plus 4 in our equation. So 1 equals 1, which is a true statement. So the answer to this first question is yes. Using the same point, does the point -3, 1 lie on the line y equals -2/3 x minus 1? So we're going to take the same approach, substitute in -3 for x and 1 for y in our equation. So we have 1 equals -2/3 times -3 minus 1. 1 equals, so -2/3 times -3 would be +2 minus 1, which will give us 1 equals 1. Again, true statement. So the answer to this question is also yes. So this means the point -3, 1 is on both of these lines. Okay, so what that means is that this point is their point of intersection. But let's confirm that graphically. Graph both lines on the same set of axes. Don't forget to label both lines. So we'll start by graphing y equals x plus 4. So that line has a slope of 1 and a y-intercept at the point 0, 4. 1, 2, 3, 4. So 0, 4, slope of 1. And I'll use the line tool to make sure I graph a straight line. And we'll label that as y equals x plus 4. And then y equals -2/3 x minus 1. That line has a slope of -2/3. And the y-intercept is the point 0, -1. So 0, -1. Slope of -2/3. So down 2 to the right 3. And then the other direction, up 2 to the left 3. Up 2 to the left 3. Up 2 to the left 3. So there's our line, and we will label that as y equals -2/3 x minus 1. So our point of intersection is right there, which is the point -3, +1, which is the point we were asked to confirm was on both of these lines in that first slide. Okay, so what does that point -3, 1 represent? Well, the point -3, 1 is called the solution of the system of equations y equals x plus 4 and y equals -2/3 x minus 1. So just to define, a system of linear equations is two or more linear equations that use the same variables, and a solution to a system of linear equations is any point that lies on each line in the system. Okay, so in this case, the point -3, 1 is the solution because it's the only point that lies on both of these lines. So now, how many times can two lines intersect? Well, in the last example, we saw that two lines can intersect at one point. Okay, so let's draw an example of that. So we have a line there, and let's say we have a line there. So they intersect once. And the solution, so the solution, there is the point. Okay, whatever the point is. Now, what's another case that we could get with two lines? Well, we could have two lines that are parallel. So we can have the blue line, and then we can have the green line. Those are parallel lines, so they are never going to intersect. So 0 times. And the solution we would have here is no solution. There is no point that falls on both of these lines. And then the last case is where the lines are the same. So let's say we have our blue line, and then our green line is exactly the same line. So how many times would those two lines intersect? Well, that would be an infinite number of times. And our solution set is going to be all points on the line. Okay, and the idea here is pick one of the equations because technically they're the same. So we might write all points on the line y equals x, or y equals 2x plus 3. Okay, whatever the case might be. But that's how we're going to write up our solution. Okay, so here are the three different possibilities when we're solving a system of linear equations. 1 point of intersection, 0 points of intersection, or an infinite number of intersection points. And this is what our solution would look like in each of those cases. So now let's get to solving. Solve the following system of linear equations graphically. So both of our lines are in point-slope form, the first being y minus 4 equals negative 3x plus 1. So the slope of that line is negative 3. The point on that line is negative 1, positive 4. So we plot the point negative 1, positive 4. Slope of negative 3. And we'll graph our line. And make sure we label that. So y minus 4 equals negative 3x plus 1. And then the other line, y plus 4 equals 1/4 times x minus 6. So the slope of that line is 1/4. And the point on that line is 6, negative 4. So 1, 2, 3, 4, 5, 6, negative 4. Slope of 1/4 label our line, y plus 4 equals 1/4 times x minus 6. And our point of intersection is the point right there. So that point is 2, negative 1, 2, 3, 4, 5. So 2, negative 5. So that point is the solution to our system of equations. Now, if you wanted to check that this point is correct, we can do the same thing we did in the first slide of this video. We can plug this point into the first equation, we can plug this point into the second equation, and each time we should get a true statement. If we don't, well, most likely what happened is one of our lines is graphed incorrectly, so then go back and check all of your work. Also, as far as labeling is concerned, whenever you have more than one graph on a set of axes, we need to make sure we label each graph so we know exactly which graph goes with which equation. Our next example, y equals x minus 2 and y minus 5 equals 1 times x minus 2. So the first equation is in slope-intercept form. So the slope is 1 and the y-intercept is the point 0, negative 2. So plotting the points on that line. And now we'll graph that line. And label it. And then y minus 5 equals 1 times x minus 2, so that's point slope form. Slope of the line is 1. The point on the line is 2, 5. So 2, 1, 2, 3, 4, 5. and a slope of 1. Let's fix this line. So that's y minus 5 equals 1 times x minus 2. So these two lines are parallel. So that means that there is no solution. Okay, and we can look back at our work, right? Both lines had a slope of 1, and then we have to just check to see that they don't go through the same points. So one has a y-intercept at 0, negative 2, and then looking at the other line, the y-intercept was 0, 3. Okay, so those two lines are never going to intersect, therefore there's no solution to this system of equations. Solve the following system of linear equations graphically. So the system is 2x minus 3y equals 6 and x equals 6. So this first equation we could solve and put it in slope-intercept form, or we can just find the two intercepts. Okay, so the x-intercept is a point whose y-coordinate is 0. So plugging in 0 for y, we'd have 2x minus 3 times 0 equals 6. 2x equals 6, x equals 3. And then the y-intercept is a point whose x-coordinate is 0. So 2 times 0 minus 3y equals 6. So negative 3y equals 6. Y equals negative 2. So if we have those 2 points, we can plot those 2 points, 3, 0, and 0, negative 2. And we can connect them to create our line. And that is the line 2x minus 3y equals 6. And then x equals 6 is a vertical line at 6. 1, 2, 3, 4, 5, 6. And we're going to graph a vertical line there. So that's the line x equals 6. So our point of intersection is right here, which is the point 6, 2. Now it should make sense that the x value of our solution here is 6 because we have the vertical line x equals 6. So only points with an x-coordinate of 6 are on this line. Okay, so if there's a point of intersection, it has to have an x value of 6. Okay, so this is a nice example where we get to refresh our memory on how to graph just using the intercepts, and we also added a vertical line. Our next example, y plus 7 equals negative 4/3 times x minus 3. So that's point slope form. The slope is negative 4/3. The point on that line is 3, negative 7. So 3, negative 1, 2, 3, 4, 5, 6, 7. Slope of negative 4/3. So I can't go down any further, so I'll go up 4, 1, 2, 3, 4, to the left 3, up 4, to the left 3, up 1, 2, 3, 4, to the left 3, and graph our line. And label it as y plus 7 equals negative 4/3 times x minus 3. And then the other line is in slope-intercept form. Y equals negative 4/3 x minus 3. So our slope is negative 4/3, and the y-intercept is the point 0, negative 3. So 0, negative 3, slope of negative 4/3. Well, if you notice, I'm putting the green points right on top of the red points. Well, that means that these are the same exact line. So there is an infinite number of intersection points, right? Every point on the line is a point of intersection. Okay, so how do we state that? How do we write up that solution set? So our solution, and I should label this, so this is also y equals negative 4/3 x minus 3. So our solution is all points on the line, and technically they're the same line, so it doesn't matter which equation you choose to write, just choose one of them. So I'll choose the simpler equation, which is y equals negative 4/3 x minus 3. Okay. And a good way to think of this is when we're looking for the solution, we're looking for a point of intersection, right? A point. So writing infinite or infinity, that doesn't give us a point. But by saying all points on the line, y equals negative 4/3 x minus 3, if we can come up with an x and a y value that make this equation true, well, that point is on the line, which means that point is one of the solutions to the system of equations. Okay, so we looked at a lot of different examples, and we talked about how there could be one point of intersection, no points of intersection when the lines are parallel. So similar type question here, but the points on the line are not the same. And then this last example was where there was an infinite number of points of intersection, and we write up the solution as all points on the line. In this case, y equals negative 4/3 x minus 3. So a lot of good practice with graphing and with our systems of linear equations. So try more on your own, especially to feel confident with graphing and the different types of solutions that you can get.